Welcome. In this video, we are going to take a look at problem 11. It is from chapter 6 of College Physics 2E by OpenStax. Okay, in this problem, we have a runner that is running the 200-meter dash, and they're running around the end of a track that has a circular arc. The radius of curvature of that arc is 30 meters. If the runner completes the 200-meter dash in 23.2 seconds and runs at constant speed throughout the race, what is the magnitude of their centripetal acceleration as they run the curved portion of the track? Okay, let's start with a list of what we know. Okay, the first thing we know is the radius is 30 meters. We know the distance is the 200 meters. And we know the elapsed time, we'll just say time, is 23.2 seconds. Okay, and we need to find centripetal acceleration. We need the magnitude of it. So A sub C equals what? Okay, so we can think of the track as something like this, where I put it about there. That's a radius. That's also a radius, and so is that. So it's a circular arc. All right, and we know that A sub C is V squared divided by R. Okay, we also know V is constant. And so what we can say is that V is distance divided by time. Okay, so let's substitute for the V. So A sub C is distance divided by time. That is squared, and we're dividing by R. And we have all those values, so we're all set to start computing. Okay, distance is 200 meters. Time is 23.2 seconds. We have to square that. Then we need to divide by R, which is the 30 meters. I computed that, and I got 2, not 20, I got 2.477 meters per second squared. So keeping two sig figs, because R has 1 or 2, we can say that A sub C is 2.5 meters per second squared. I hope you found this helpful. Let me know in the comments section if you have any questions or other problems you'd like to see. Your feedback is important to me, and it will help me make better content for you. Thank you for watching. Please like and subscribe, and I will see you in the next one.